Hello folks and welcome back to the Shack. This is Joe N2DI coming to you today with a follow-up on my last two FTDX10 EQ videos. I've had a few folks ask to see the power meter on my FTDX10 before and after the EQ settings are applied. Now if you've asked for this, then the results you're going to see here will surprise you. We'll get into the what's and whys later, but first let's get to that test. So if you're curious to see the impact the EQ settings have on your output power, then let's get started. Okay, this is how we're going to do the test. I've got the FTDX10 connected to a dummy load, and I've done a factory reset. So now we're looking at an FTDX10 as it would come out of the box. Next, I'm going to fast apply the gain, AMC, transmit bandpass filter, EQ settings, and processor settings. Then what I'll do is I'll switch the meter to show the output power, key the mic and talk, and show you the output. Then I'll enable the EQ and processor, key the mic, and do it again. Then we'll discuss what we see. Okay, now I'm going to quickly apply all those settings. We'll go into the menu, and we'll set the mic gain to 38. Mic EQ on. Processor level 15. AMC level 70. Go into radio setting. Mode SSB. Set the bandpass filter. Back out. Go into operation settings, TX audio. We're going to set the P parametric EQ. Now all these settings are in my previous video. Okay, so those are all the transmit settings that I recommended in my last two videos. Now I'm only focusing on the settings that you use to cut through pileups, because that should have the most impact. I'm not going to bother with the rag choose settings. Okay, the last things we're going to do before we run the test is I'm going to back out. I'm going to set the VFO to 7150. And I'm going to lock it there so it doesn't move. And I'm going to switch the meter to power, which it's already on power. Okay, great. Now we can run the test. Now, just a reminder, all the EQ settings are applied right now. Mic EQ is on and the processor level is on. Okay, now keep an eye on that power meter. Hello, hello, hello. Testing, 1, 2, testing. Hello, hello. So you see there it peaked about 50. Now I'm going to turn off the processor and the EQ settings. Okay, those are off. Now check out the power meter. Hello, hello, hello. Testing, 1, 2, testing, 1, 2. Hello, hello. So you see there it peaked up around 50 as well. So not much of a difference. Now, one other thing I want you to look at is check the power meter. I'm going to key the mic, but I'm not going to talk. And let's see what happens to the power meter. You notice there it didn't move. I'll do that again. No output power. Why? Because we didn't speak. Now let's get into the details of what we saw. Okay, so let's talk about what we saw. But first, if you find my videos useful, then please consider clicking the like and subscribe button so other hams can find my videos. The first thing that confuses new hams is that they set the radio to 100 watts, but they don't see 100 watts when they transmit. Now why does this happen? Single sideband is not like AM. It doesn't output a carrier along with the modulation of your voice. It just outputs the modulation of your voice. So if you key the mic in single sideband and you don't speak, you'll get zero output like we saw. Now, as you speak, the modulation of your voice will put out different power levels. On the peaks, when you're saying loud syllables, it will put out more power. And likewise, on the quieter syllables, it will put out less power. Now, the thing is, your power meter only shows your average power output. So what you're seeing is an average between those peaks and valleys in power. What you actually want to see is your peak power. Now, some radios have a peak hold function, but the FTDX10 does not. So what you're probably going to see is 30 to 50% of whatever power setting you set your radio to. So for 100 watts, you're only going to see between 30 and 50 watts of output power. Now, if you want to see your peak power, well, then you're going to need an external watt meter with a peak hold or an active peak reading function. I don't have one of those, but what I do have is an AURSINC TinySA Ultra Plus spectrum analyzer, and that can show you your peak power. And I'll show you how to set that up next. Now, before I hook up the TinySA Ultra to the FTDX10, I want to show you what I'm doing because it's really important. Now, what we have here on top of the FTDX10 is a massive attenuator. It's a 100 watt 40 dBm attenuator. So this can take the sustained output of 100 watts. Now, what I have attached to the end of it is an additional attenuator. Now, since this attenuator can attenuate 40 dB and 100 watts is 50 dB, I need a little bit of extra attenuation so I don't damage my spectrum analyzer. So this little guy in the end here provides an extra 20 dB of attenuation. Now, why the size difference? Well, one is meant to dissipate a huge amount of power and the other one can only take a couple of watts. So we can stick the tiny one at the end here because we're going to be dissipating a massive amount of power here. So this attenuator is never going to see that much power. So now I'm going to hook this to the output of the FTDX10 and then connect the spectrum analyzer. Okay, so now I've zoomed back so you can get a big picture of what I'm doing. So I have the FTDX10. Here's the output. The antenna output goes into the back of this giant attenuator, which gives me 40 dB of attenuation. It comes through the 20 dB attenuator, so I get a total of 60 dB of attenuation. That comes through out to the RF input on the TinySA. So this is the setup. Now what I'll do is I'll zoom in and I'll quickly run through the settings that you need to set on your spectrum analyzer to do the same test if you want to test along. Okay, so the settings you're going to want to apply are go into frequency and then zero span and set this frequency to 7.1488 megahertz. Now we're going to go back into frequency and we're going to set the resolution bandwidth to 30 kilohertz. Now we want to go into level and then attenuate and set this to 0. So the TinySA doesn't apply any attenuation since we already have 60 dB of attenuation ahead of it. Now if you make your measurements now as is, they're going to be off by 60 dB because we have 60 dB between the radio and the spectrum analyzer that the spectrum analyzer doesn't know about. So to let it know that it's there and to mathematically make up for it, you can do that by going into level and then external gain and let it know about the amount of external gain we have, which is minus 60 dB. You just hit the 1x here. So now it's going to make up for that 60 dB. And the last step we're going to want to do is go into the trace and then calc and set it to max hold. So this way it'll hold the trace at the maximum power output that it sees. Now all we have to do is key the mic and talk. Hello, hello. So now I want to draw your attention to the number up here. That's 49.7 dBm. Now if you convert that to watts, that's about 94 watts out. Now again, this is with the mic EQ and the processor settings off. Now I could switch those back on and we can rerun the test. Okay, so now I switched the mic EQ and the processor level back on. Now we have to get this trace to start calculating again, so we'll switch it off. So it resets, it drops that max hold that it had. And then let's switch it back on. Max hold. And now we can key the mic and talk again. And now this time the EQ and the processor level's on. Let's see what the difference is. Hello, hello. Okay, and let's look at that value again. 49.7 dBm, which again is about 94 watts out. So you see the EQ and the processor really don't make a difference on the total output. If your radio is set to 100 watts, you're going to peak at 100 watts. Okay, so to sum that up, when you're using single sideband, your peak power will be whatever you have set your radio to. So if you set it to 100 watts, you're going to be very close to 100 watts, if not exactly 100 watts. But your power meter is going to show you your average power. Now, the only thing that really impacts your average power is your microphone gain and your processor level. But what all these settings really are going to do is to help your intelligibility. And that helps a lot in poor conditions when your signal is weak or when you're dealing with crowded bands. So it's not always about power output. You want the person on the other end to be able to understand what you're saying in those challenging conditions. Remember, if you find my videos useful, then please consider liking and subscribing to help other hams find it. So from the Shack of Joe, November 2, Delta, India, I wish you all good health and 73. Bye-bye.